Okay, so there is already the one hand in the air. Mark.
Good afternoon. My name is Mark Strauss. I'm from Aqua Metals. I'm a recycler. I had a question for Tomasz and about cathode. So if I heard you correctly, in order to be paid for a cathode, you have to scale that technology commercial and be qualified for up to 3 years before you'll be paid by the cathode purchaser. Is that correct? Is that, if I understand the cathode qualification process correctly?
Well, the cathode qualification process is typically, the OEM or the EV maker qualification, which takes a lot of time to pre-validate and qualify the process. So there are a number of steps, and if we divide it into two, there's typically the product validation and the process validation. So today at Ascent Elements, we have 4 locations in the US. 2 of them are the pilot scale locations, and 2 are the commercial scale. So the 2 pilot scale, we have one of the pilot scale operation for the precursor, and the other in Michigan for the cathode active material. So today we produce the cathode active material at the small rate of a couple of tons or up to 100 tons of the cathode active material per year. So today we engineer and develop the cathode active material, and we pre-qualify that with the OEMs as the product level validation. Once we have the commercial scale operation ready in Kentucky, we would be repeating the same process from the material produced from the large production line to prove that the same specification and the same quality is produced over there. So this will be called the process validation. So combine those two is going to be, again, depends on the OEM, depends on the EV, depends on when they have the next window to introduce the next battery material. That's, combined is around 36 months. But we are shortening that by delivering the material from our pilot line operation. Again, the pilot line operation is not the lab scale operation. We have the lab scale operation. The pilot line is fully functional process line with the same equipment, same process steps, just smaller scale.
Okay, I have one more question. So I really like the fact you've shown that the cathode works similar to a virgin cathode material. And I have a confession. In my graduate work, I was right next to Yan Wang, not with his work, but different work. Mm-hmm. And I've seen his data for years and years at the lab scale. So I understand hydro is much more scalable than cathode manufacturing. You're comparing a commercial cathode product to a laboratory scale cathode product. Your product is better, right? Correct?
I'm comparing the commercial scale cathode to the pilot line produced cathode.
Okay.
So from the process, just
okay.
smaller reactors, smaller ovens, everything in the smaller scale.
But still a different scale.
It's a different scale, yes.
Okay. From what I understand, there's a limit of manufacturing for cathode material, meaning what can be shown at the pilot may not scale fully to the commercial scale. It's not necessarily the same way with hydro material. I don't know if you have any thoughts about that comment of mine.
So we are using the production intent equipment on the pilot scale. Uh-huh. So also the scaling up the pilot line is not only buying the larger components, larger lines for that. It's the scaling up. It's both increasing the capacity of each step, but then also installing the parallel lines of operation. So the scale of we run the pilot line is representative of what we will be doing on the commercial line. Most of the vendors will be the same techniques. We will be going up from the few hundred liters reactors to the few thousand liters reactors as the example, and then we would be multiplying that as the individual lines. So
thank you.
So any other questions?
Hi, it's Steve Sloop with Onto Technology. And for Alexandra, this is great work, really. It was a lovely presentation. And I was wondering if you saw any differences between the bulk properties of cathodes and anodes for, let's call it over-discharged versus end of state of charge.
So can you specify more what bulk materials do you mean in detail?
I mean, like, if you take an X-ray, let's say, do you see some differences in 003 reflections of an NMC if you over discharge it versus if you don't?
Yeah, the great variations are, of course, the plating, for example, of the materials. That looks normal in beforehand, for example, for NMZ. And the thing is, for our different types of NMZ batteries we used, they all look like that as the example I was showing. They were all this great, this great plating, at least for the NMZ 101. Maybe there should be also other investigations, for example, for NMZ 811, for example. That at the moment I don't have this battery at my storage, so I can do investigations on it. That's my problem.
And then just a quick thought. The copper's getting into the cathodes. Is that sitting on top of a, let's say, a current or like a carbon current additive, or is it just anywhere and everywhere, or
this is less like it was at the SEM pinch. It was like a plate really on the NMC, for example, or on the LFP. It was really sticking on that problem. It was not everywhere in the NMC. So inside the NMC particles, which we're seeing in the SEM, there was just the binder, and the copper was really plating on site these outer particles of the NMC.
Thanks.
My pleasure. Thank you for the question.
Hello, Sonetner from MIBA. Question for Thomas. I found your chart really interesting about the 100 kilowatt hour battery. And my question is about regulatory drive, let's say. If you see on the right side, there is the things that have the highest value, let's say lithium, and on the other side, you see there is 55% of weight of battery that basically has no value. If you think about the recycling, do you think there will be a drive from the recycling to change battery designs based on, I mean, you can see directly this, you can see this in your graph that basically tells if the materials are so valuable at the end, you should change the battery design to more easily recover them.
That's a perfect question, and really appreciate that. So if there are any battery designers or the vehicle producers or the battery OEMs, please take recyclability into the consideration. So what we are seeing in the market, in the industries, is actually the different directions. So that's the headwind for us. So if you think about the battery pack, the couple of years ago, it was the structure of the cell to module, mechanical connection, then module to the battery pack, mechanical connection, battery pack as the separate unit, easily removed from the vehicle, standalone unit. What we see today, it's all getting integrated. So right now, it's very common that the cells are integrated into the battery pack or the electrodes into the module. So different approach. If you see, I don't want to name those great guys, making the beautiful cars, but some of the design, you see the cells being put into the enclosure that is not the battery enclosure, but it's part of the chassis, it's part of the vehicle structure. And you see all of those cells, the space between the cells filled with the material that we can't even name it yet, unless we do the re-engineering. And recycling of that, it's extremely difficult. Number one, you are recycling part of the vehicle. Number two, if you have all of that fancy red material, you know, everyone in the recycling knows what I'm talking about, which is filled in, and then you have to remove that, right? That material has to be removed during the pre-treatment, mechanical shredding. If not, it ends up in the black mass and makes the future processing more complicated. So you need more time. It's more expensive to further do that. So I see, unfortunately, the industry going the other way, but that's a challenge for us to work around and implement different technologies, something that we have never used in the recycling industry to remove material like that. So I don't want, you know, to share too much, but like very low temperature treatment is being considered to recover that material. Is something, you know, that is new, and we are approaching that. But yeah, very few battery designers are really asking us for the recommendation or help in designing the battery pack. The main target, the main objective is to design the battery pack, the lowest cost, the highest energy density, which involves designing the cells into the structural frame of the vehicle.
If I can add to that, this is true for the mechanical aspect, but it's also true for the chemical aspect. You know, our job is to remove all the impurities, okay, that to return the materials. In our case, we're producing the lithium carbonate or the nickel sulfate. We need to find all the impurities and remove it. And when chem producers are adding special chemicals and they are not telling anybody about those chemicals, it's very hard after that at the hydro process or any other processes to see those chemicals. And so we need to work together in the battery design. The eco design, it needs to happen now so it can make the job of everybody easier at the end, because it's just going to be more expensive otherwise.
Maybe in between, I'm just squeezing one question to Alexandra in between. Then next one is yours. So you spoke about over discharging, and I was wondering, is then the next step, thinking practically out of your researches, can you, or is that an objective to figure out the ideal discharging point? So we all know in Li-Cycle's case, that's not the big deal, but in general, discharging makes sense before the pre-treatment, and over-discharging is getting us again in difficulties. So I somehow have the fantasy somewhere is a sweet spot where you should have the battery or the cells then. Is that a topic for you, or can you give us maybe an idea of that? Where is the ideal point of discharging then?
I like this question. It's really, really nice. Thank you for that. Yeah, the best discharging point at the moment for the mechanical recycling for the anti-bladed process screens at the moment is really that PTC point. The problem is that it can happen that we have capacity loss from the cells inside the whole battery. And this capacity loss of different cells, which we can yet not orient, for example, is the problem that then different cells are more discharged or charged than other cells. So the idea would be that we can have an information from every cell of the whole battery pack inside, for example, our vehicle, and have a knowledge about if there's a high capacity loss, which can lead to this over discharging, as, for example, the same current is applied like for the other cells. And then, for example, already put that cell out and put a new cell in to have everywhere the same capacity to overcome this over discharging. Otherwise, we have this conflict with the recycling process.
Okay, thanks. So,
Hi.
yeah, thank you.
Thank you.
A question for all of you, or actually for the whole recycling industry. Dirk Spiers, New Technologies. The economics. Tomasz, you already mentioned that it will become, or it is becoming more and more difficult to get battery packs out of the vehicle. And when it's more difficult, it's more expensive. Transportation will be an increase in cost. And then the three-letter word LFP. I saw your slide, and you said on a 100 kilowatt-hour battery pack, you recover about $6,500. With LFP, you can take off everything except what you get for the lithium and maybe for the graphite. So, tell us about the economics if LFP is getting a 30% market share.
So this is the question that my microphone typically, has a troubles when I try to answer. So no, thanks for the question, Dirk. So LFP recycling is a challenge, not because of the technology, but because of the economics of doing that. So to make the statement short, we need the government support to do the LFP recycling. So if government wants the LFP elements to be returned back to the battery industry, the circularity, they have to put demand on a recycling content on the LFP. And that's a challenge, because in some cases they may increase the value or the cost of those battery materials. In the LFP, we can recycle today the lithium. I mentioned Ascent is working on recycling, recovering the graphite. We can do that. And that technology, that process, it's around the break even. It depends on the lithium pricing. It's a little bit of profitability, or the pricing is lower. It's losing money. So it's very sensitive. So industry won't invest into that unless there is the demand. And I've just said that may increase the cost of the materials, that no one wants to hear that. However, if I switch back to the NMC, with the demand we are seeing, with that compliance starting in EU 2027, and then the demand for the recycled content 2030 and 35, the industry leaders believe that the value of the recycled materials will be at premium comparing to the virgin material because of the shortage. So if this is the case, then the industry would need to be ready also to pay premium for the LFP. But currently, without the legislation, without the demand from the government, I don't see much of the LFP recycling technologies being invested into the market.
And maybe the good news also is that the NMC market is still there and is growing. So yes, the LFP market is growing, but they are both growing at the same pace.
Yeah, and one more comment, Dirk, and to all of you. So why there is so big interest in the LFP today? It's because the cost of the value of the iron phosphate is significantly lower than the other materials. So what if we, in 20 years in the future, if we have enough of the NMC feedstock that we can recycle, that we can urban mine versus source from the virgin material, if that's in the closed loop, if the closed loop is efficient enough, so that means if the value of the NMC to produce, or the value materials to produce NMC, it's only the cost of the processing, not the cost of the virgin material, would we still be interested in the LFP, or we would rather go, no, we all want NMC, the higher energy density, higher performance?
No, I would agree with that statement. And I think that the attraction of LFP is not so much it's a lower price, it is a more stable price. So it is easier for the OEMs to predict into the future, to calculate, what they're going to do in the next couple of years.
Fully agree. And then if the cost of the materials is cost of the recycling, then the NMC price would be even more stable than the price of LFP.
Cool. Okay, and I think here maybe last question, because we're 5 minutes, but it's great that you have so much interest, and then maybe looking around once. Go ahead. Yeah.
Yeah, so thank you very much for the presentation. So what we have seen from your boss is that there is an improvement of the profitability on the interest if you have a vertical integrations like the cathode and so on, which means that when we become a recyclers, we better have to have an horizontal, I will say, performance, saying that the critical size of the recycling plant should be big, right? Big enough. You have mentioned 150,000 tons. Umicore this morning also mentioned 150,000 tons. So do you have an opinion for recycler? What would be now the minimum critical size in order to still get tractions from the cathode manufacturer and from the market?
Yeah, if I can
your
start,
stage.
well,
Your stage.
but it's you guys doing growing that industry as well. So we have to split that closed loop into two steps, into two phases: the pre-treatment and the post-treatment. So the big challenge in the pre-treatment is cost of acquiring the batteries, cost of logistic, discharge, disassembly. So especially the logistic part, it's very complicated. And then if you think what needs to happen to collect the end-of-life batteries, it's easy if you collect few batteries here, few batteries there. But in the future, if you have to collect hundreds of batteries every day in the multiple locations, there has to be the contact made, it has to be the commercial transaction made between the owner of the battery and the recycler. Someone has to certify the battery is ready to ship. Someone has to decide if the battery requires a special packaging. If so, where is the packaging, the logistic route, all of that. That's extremely complicated, extremely expensive. If we can reduce that, if you can reduce that logistics, that's a huge savings. And what I see you guys are doing, and really appreciate that as the your industry colleague, is building the network of the pre-treatment to reduce that complicated logistic. Then once the batteries are converted into the black mass and all other components like the aluminum, copper, plastics are sold back to the industry, the black mass logistic, it's very easy, it's very cheap comparing to the end-of-life batteries logistic upfront. So today, our colleagues from Asia, they pay to ship the black mass from US, from Europe, all the way to Asia, and return it back to US and Europe, either in form of the precursor and the cathode material, because it's very cheap. So then it makes sense to combine the precursor, even metal extraction precursor, and the cathode production into the large production campuses to lower the cost, economy of scale. But the pre-treatment, it has to be the network to allow the collection. And what I really hope for the industry is to partner together, right? So once the battery is shredded, it's not the Volkswagen, it's not the Volvo, it's not the SK or CATL battery anymore. It's basically the mass of lithium, nickel, cobalt, graphite. So who cares where was the source if we know exactly what is the amount of the black mass? So instead of letting the logistic folks to make a lot of money to ship back and forth, why don't we trade between us those critical metals to reduce the logistic and further process out of the big refineries?
Will you, or shall I?
Yeah, because my question is very much related to the hydro critical size rather than what I think is
maybe I'm switching that in very shortly. So we made our assessment on that, and we are convinced that you have a specific size of factory when you're speaking about hydromet, because you have with what we call spoke, because it's a standard, also a branding thing, but it's a standard process line. It is designed once and it is everywhere the same. So more or less we know how the spare parts are managed, etc., etc. It's a bit like the McDonald's principle, you can say. It's always the same line everywhere. And that is giving us the opportunity to expand very, very quick. And there you have an investment which is, let's say, you can oversee it very good, and it is not having this volume where you have to go and scale. And then you have to do your break-even calculation. How much material out of the spoke or the pre-processing can you directly route in other areas so that the logistics network is absorbing that locally, and you have then only the whatever hopefully 50+% of black mass to be transferred then to a huge investment, which is obviously whoever is doing that and however it is done. It is not, it doesn't matter if it is the technology, Umicore or Lifecycle or whatever, it is a huge investment itself. So you can more or less say, okay, it's a bit like a small gigafactory, what we're building there. And the key point is to put all those factories in a line, not in a line, in a loop, and which is then also adding the converters and the chem and the pchem and all that part should be, it's a bit an orchestra at the end. So everybody has to do their own math on which size should it be. But on hydromet, we are absolutely convinced it fully makes sense to go in that size, what we are at the moment doing. And even you see from our learning what we've announced for Europe and what we are executing North America, why is there a size gap? I don't want to get into deeper. You can make your own mind about that. That is very simple, one part of the answer. And I really appreciate that feedback. And last sentence from me, we all have to think a bit like a reverse Amazon logistics. It's maybe a bit crazy comparison, but what their last mile is our first mile. And the first mile is our issue, because there is all those risks, there is all that waste regulations, etc., etc., etc. As soon as we have managed the first mile into the spoke, we are having much more, let's say, predictable and better manageable products on the road and in the facilities. And I think you can agree on that. And that is why it makes sense to do so. Yeah. Okay. I was just told that one sunglass is missing here, so you can catch that up here. We are a bit in the overtime. First of all, because I hope you are still with us. Alexandra, thanks again for dialing in. And
Thanks for the opportunity.